Good morning, guys. Welcome to my YouTube channel. And this time we are going to take up or discuss the circular motion by yours truly. My name is Dante M. Aguila, your teacher in science. In the previous modules, you learned about Newton's three laws of motion, such as the law of inertia, the law of acceleration, and the law of interaction. You did some tasks and exercises to gain insights about the relationship among force, mass, and acceleration. In grade 7, you are able to describe the motion of an object in terms of its speed, velocity, and acceleration. In this module, we will explore uniform circular motion and link it to the three laws of motion. We have the most essential learning competency and objectives. In this module, you will learn how to relate laws of motion to bodies in uniform circular motion. Specifically, you will learn to, number 1, describe uniform circular motion. Number 2, explain how the first law of motion or the law of inertia is related to the objects moving in uniform circular motion. Before we start our lesson for this module, let's revisit the Newton's laws of motion. So we have the Newton's three laws of motion. The first one is the law of inertia or the first law of motion. An object at rest will remain at rest unless an external force acts on it. And a moving object will continue moving in a straight path unless acted by an external force. Okay, we have the law of acceleration. The greater the mass of an object, the more force is needed to accelerate that object. And number 3, we have the law of interaction. For every action force, there is an equal and opposite reaction force. So those are the Newton's three laws of motion. When we say uniform circular motion, it is a motion along a circular path in which there is no change in speed, only a change in direction. So we have the word velocity or constant velocity. Constant velocity tangent to path. As you will see, we have the black arrows here. So this is called the velocity. Tangent to path. In other words, nandun po siya sa path ng circle. Okay? We have the word centripetal force. The centripetal force, we have the yellow arrow right here. So this is the centripetal force. Okay? Toward the center. Question. Is there an outward force on the ball? Mayroon bang outward force doon sa ball? The right answer is yes. Ang tawag doon sa outward force sa ball ay tinatawag na centrifugal force. Meaning, it is defined as the apparent force that is felt by an object moving in a curved path that acts outwardly away from the center of the rotation. So, mayroon po siyang tinatawag na centrifugal force. Circular motion again. Suppose you drive a car in a circle at a constant speed. Even though your speed isn't changing, you are accelerating. So this is because acceleration is the rate of change of velocity, not the speed, and your velocity is changing because your direction is changing. Ang tawag po doon sa acceleration na yun ay centripetal acceleration. Again, centripetal acceleration is an acceleration where it is the rate of change in velocity, and we have the circular motion is due to forces acting perpendicular to the direction of motion. Such forces are called centripetal. We have the centripetal center seeking force. The force that changes the straight path of a particle into a circular or curved path is called the centripetal force. It is a pull on a body and is directed toward the center of the circle. When drawing natin, we have the boy and may hawak siyang string na may ball sa dulo. Pinapaikot niya. Okay? So, the force inward at the center is called the centripetal force. The red arrow is the centripetal force. Centripetal forces, examples. Number one, friction. As in the turning car example. So, the car running on the curved road. So, friction. Number two is tension. Tension as in a rock whirling around while attached to the string. Or a tension in the chains on the swing at the park. O yun, sa mga carnival, di ba? We have the gravity. Gravity, the force of gravity between the Earth and Sun keeps the Earth moving in the nearly circular orbit. Yan po. May mga orbits po yung mga planets natin. That's why hindi po sila nagkakabungguan, but with the help of the Sun. Kasi po yung Sun natin, may tinatawag na gravitational pull. Right? Yung gravitational pull na yon, let's consider the figure given here. An object tied to a string is moving in a uniform circular motion. The object is represented by the orange ball. When the string is suddenly cut, there is no longer net force acting on the object. So the tendency of the object is to move in the straight line represented by the red arrow, not on the circular path represented by the green arrow. We have the Earth stays on its orbit. So we have the third planet, the Earth. Because the gravity of the Sun pulls the planet in. But the motion sideways keeps the planet swinging around. Without that sideways motion, it would fall to the Sun, and without the pull towards the center, it will go flying off in the straight line, as explained in the law of inertia. We have the vocabulary list. You may refer to the following vocabulary words used in this module. We have the centripetal force. A force acts on a body moving in the circular path and is directed towards the center around which the body is moving. Constant speed, unchanging or no change in speed. Inertia, tendency of an object to remain at rest or in uniform motion in the same direction by virtue of its mass. We have the law of inertia, law of motion, which states that an object at rest will remain at rest. A moving object will continue moving in the straight path unless acted upon by an external force. Uniform circular motion, motion of an object moving at a constant speed on a circle but with changing direction. Guys, this time I will give you an additional video regarding the circular motion. Stay tuned.
Have you ever been on a merry-go-round in a carnival? As you are swinging around, you are actually undergoing circular motion. In this video, we will explain why an object moving in a circle with a constant speed has a changing velocity. First of all, what's the difference between velocity and speed? Speed is a measure of how far something travels a distance in a particular time. For example, a car travelling at 25 meters per second or a person jogging at 4 meters per second are both measures of speed. Velocity is a speed in a particular direction. For example, a van travelling north at 25 meters per second and a raindrop moving down at 1 meter per second. For each of these statements, decide whether they are a measure of speed or velocity. Pause the video while you think. When an object is moving in a circle at a constant speed, it has a certain velocity, v, which is at a tangent to the circle. At the same time, the mass is also accelerating towards the center of the circle. But you may be wondering, why is the object accelerating when the speed remains constant? To understand this, we must review the factors that cause velocity to change. As you know, a change in velocity results in acceleration from this equation. Acceleration equals the change in velocity over time. The two ways in which velocity can change are a change in speed or a change in direction. So when you're moving in a circle at a constant speed, your velocity is constantly changing because the direction you are moving in is also constantly changing. But you may be wondering, what actually causes the acceleration? As you know from Newton's second law of motion, the net force acting on an object is directly proportional to its acceleration. In the case of circular motion, the net force that causes this acceleration is called the centripetal force, and it is always directed towards the center of the circle. You can easily test this by attaching a ball to a string and swinging it round your head. The speed of the ball is constant, but you need to keep pulling the string to make it go in a circle. What direction do you think the ball will follow if you suddenly let go of the string? Is it in the red direction or the blue direction? The ball will continue to travel in the same direction, so with the same velocity along the red direction. Try it yourself and see. So that's how velocity can change whilst speed remains the same, by changing direction and not speed.